Hey there, I'm glad you're here. This is Middle School Math. I'm Dr. K, and today we're going to talk about inequalities and how they react to different operations with, specifically, negatives. Let's get on this. So, I want you to think about inequality symbols, less than, greater than, less than or equal to, greater than or equal to. We've got two numbers here, and I wonder what symbol you would put in between them. So, negative 16 and 8. I would put a less than symbol. And that means that negative 16 is less than 8, which we know to be true. Remember, some people think of this as like a Pac-Man or a monster. It needs to eat the larger thing. So if that helps you, great. Now, what's interesting is how inequalities change kind of depending on what you're doing with them. So I want to show you some examples. Let's say we added 3 to negative 16 and 8. That would give us negative 13 and 11. Well, negative 13 is still less than 11, so nothing has changed. What if I went back to negative 16 and 8 and I subtracted 5? Negative 16 minus 5 is negative 21. 8 minus 5 is 3. And negative 21 is less than 3. So far, nothing's really changing, nothing too surprising. And hopefully what you're thinking is, well, if I add 3 to both things, then the larger number is still larger. If I subtract 3 from both things, then the larger number is still larger. Well, what happens if I double both things? If I multiply by 2, negative 16 times 2 is negative 32. 8 times 2 is 16. The larger number is still larger. Okay, let's try something else. What if I divide by 4? Negative 16 divided by 4 is negative 4. 8 divided by 4 is 2. The larger number is still larger. Now, there are some interesting things that can kind of mess with our inequality. So let's do this one more round with just a little shakeup. Now I want you to take negative 16 and 8 and multiply by negative 1. So we know that negative 16 is less than 8. That we've established. If I multiply by negative 1, what happens? Negative 16 times negative 1 is positive 16. 8 times negative 1 is negative 8. All of a sudden, my sign needs to flip because positive 16 is larger than negative 8. Okay, so multiplying by negative 1, that messes with our inequality a little bit. What happens if I instead divided them both by negative 2? Negative 16 divided by negative 2 is positive 8. 8 divided by negative 2 is negative 4. Same thing. My symbol has changed. So I had a less than in the original example, and now all of a sudden I'm working with greater than symbols. Let's keep going. Maybe those are a fluke. Let's see if it continues. What if I divide both numbers by negative 4? Negative 16 divided by negative 4 is 4. 8 divided by negative 4 is negative 2. And I see that my sign still needs to be flipped. Okay, one more take. What if I multiply by negative 3? Negative 16 times negative 3, that's a tough one. That gives you positive 48. 8 times negative 3 is negative 24. So I'm hoping that you're noticing a pattern here. When I multiply and divide by a negative number, and I showed you kind of a variety of numbers just to show you that it kept happening, your sign gets flipped around. And that's true in all inequalities. So when we're solving, if we have to multiply or divide by a negative, our sign gets flipped around. And essentially why that's happening is because if you multiply a negative number, let's say negative 2 for ease. Negative 2 is pretty close to 0, right? If I multiply that by a negative, what happens? Any negative times any other negative becomes a positive number. Well, if I'm comparing it to a positive number and I multiply that by a negative number, it's going to come over here. So those have essentially swapped places. What if instead I had two positive numbers? Let's say I had 5 and I had, 100. If I multiply both of these by something negative, let's say just negative 1 for the sake of ease. 5 times negative 1 into 5, right? So that would move left to some extent. 100 times negative 1 is negative 100. It would move way further left. So even though positive 100 is larger, when I multiply it by a negative, it actually becomes the smaller number. It's further away from 0 on the left-hand side. So that's a consistent pattern with inequalities. Now let's look at some examples and how that applies to you as you're solving inequality type problems. Here's example 1 of 3 that I want to take a look at. Now, you'll solve this just like you would any other inequality. So you want to balance both sides, right? You want to subtract 5 to work toward isolating the variable. Now 5 minus 5 is 0. That leaves me with negative 3x on the left-hand side is greater than 24 on the right-hand side. But why this information matters is now I have to divide by a negative 3. And as we just learned, inequalities are highly affected by multiplying and dividing by negatives. So instead of getting x is greater than negative 8, we actually have to flip our sign when we divide by a negative to get to the correct answer. So x is less than negative 8. Now, nothing else is impacted by that multiplying or dividing by a negative except the way that your sign goes when you're solving. So when you get to the graphing portion, you're actually going to do the same thing you've done before. You'll just use that final answer to graph. So now I want to show that x is less than negative 8. Here's another example, and I'm throwing in some distributing along with having most of the work on the right-hand side of that inequality just so you can get a good sampling of inequality examples. So I'm still trying to balance the left side and the right side. I now see that I have a number that needs to be distributed on the right-hand side, which gives me negative 6x and positive 36. On the left side, nothing has happened yet. I still have 12. Now, if I want to isolate that negative 6x, I'll need to subtract 36 from both sides. On the right-hand side, I have just negative 6x. On the left-hand side, I'll have negative 24. And because I have not multiplied or divided by a negative yet, I'm still going to keep my symbol as a greater than symbol. But at this point, I need to get x all the way by itself, and I need to divide by negative 6. And as we've learned, like we said, inequalities are highly affected by multiplying or dividing by a negative. So I get my answer of 4, but I have to flip the sign and then put my x. So anytime you multiply or divide by a negative, you have to flip the sign in your inequality. Now, for the sake of graphing, I often say you actually need your variable first. So I'm going to flip this one around again to get my variable first. So previously, I could see that x was greater than 4, so I need to make sure that x is still greater than 4 when I rewrite my answer. And rewriting it can help because that helps me see that x is representing values that are greater than 4, which tells me that I circle my 4 and point my arrow towards the right-hand side. Let's take a look at one last example, and then we'll kind of wrap it up and talk about the high points, the big takeaways from this lesson specifically. So again, I want to isolate that variable. This one looks a little different because x is being divided by negative 4, which I haven't shown you yet. So I'll still solve very similarly. I still need to get rid of that negative 8 on the right-hand side. 8 minus 8 gives me 0, which leaves me with x over 4. It did have a negative. I'm going to bump that negative down with the 4, just so that it's with a number and I can really utilize it. My sign is not going to change because I haven't multiplied or divided by a negative. All I did was subtract, and we don't flip signs for any addition or subtraction, only for multiplying and dividing by a negative. On the left-hand side, I get negative 3. Now, in this example, x is being divided by negative 4, and the opposite operation would be to multiply by negative 4. I'll do that on both sides. On the left-hand side, multiplying by negative 4 gets me to positive 12. And on the right-hand side, x is being multiplied and divided by negative 4. Those cancel, and I'm left with just x. But because I multiplied by a negative, I do have to flip my sign, which makes it say 12 is less than or equal to x. Before I graph, I do like to rewrite it. X and 12, I want the variable to be first. I just really think it helps people understand which direction it should be going. The arrow, the monster, the alligator, however you like to think of that symbol, was kind of pointing towards the x, so I'm going to make sure it's still pointing towards the x and still has the equal to portion on it because that really matters. So I got to my final solution. On the graph, that will look very similar to the other examples. I like to put the number that I'm working with, in this case the 12, in the middle, 2 above and 2 below. Remember, the larger numbers go on the right and the smaller numbers go on the left. I will circle my 12, and this time because I'm looking for things that are greater than or equal to 12, I have to remember to fill in that circle, and then I can point my arrow towards the right-hand side. Here are the big takeaways I really need you to know about inequalities. Remember, when you're solving an inequality, you're doing the exact same thing you did when you solved an equation. You're still using opposite operations. You're still balancing both sides. You're still trying to isolate a variable. You might combine like terms or distribute or any of those other things that you did when you solved an equation. The difference here is that it's not an equation in that it has a less than sign or a greater than sign or what have you. Remember that when you divide or multiply by a negative, specifically by a negative, your sign has to flip. You can think back on all of those examples where we added something to both sides and the sign stayed the same. We subtracted something from both sides and the sign stayed the same. It wasn't until we multiplied or divided by a negative that that sign had to flip in order to still be a true statement. Remember also that when graphing, it sometimes helps to flip the answer around if your variable is last to make it first. If you're going to do that, let's say you had, 3 is greater than x. If you're going to do that, flip everything, including the sign. That helps it stay an equivalent solution to your inequality. If you forget to flip the sign, you will get something that is not true, that is not the solution to your inequality. Remember also that you sometimes fill in the circles. That's if you have these equal to signs, and you sometimes don't. So that's an important piece to the graph of the solution. As a teacher, I know that when we look at your work on inequalities, we're really looking for both parts. We want to see that you can get to the answer, and we want to see that you know what you're doing with a graph of an inequality. So go solve and graph all the inequalities. I am confident that you now know how to solve all of the world's problems, or at least those that have to do with inequalities. So go, solve, graph. Have a great day, and I'll see you next time.